Welcome and thank you for giving us your time today. We are Cool as Code and we are excited to share with you our final project, Food Story. Before we get started, let's meet the Cool as Code team.
Hi all, my name is Apurva. After completing my degree in Electronics and Communication, I worked in IT in mainframes technology until 2011. After a long gap, I joined School of Code with an aim to restart my career in IT. So here I am.
Hi, I'm Priya. I've been working for over 5 years in the engineering industry. I've gone from using transportation models to help inform data-driven decision-making to developing my own tools to solve problems with the help of School of Code.
Hi, I'm Rosanna. I worked in admin and customer service. Now, with the help of School of Code, I'm limbering up my creative muscles and looking for my first role in tech.
Hi, I'm Wayne, currently working towards becoming a full-stack JavaScript developer. I love solving problems with logic. I enjoy coding as part of a team, or on my own.
Hi, I'm Wesley. After a long career working as an administrator in a further education college, I decided to challenge myself to learn how to code during the first national lockdown in 2020 and have been on the journey ever since.
Hi, I'm Godwin. I'm passionate about IT and I love coding. I'm able to work in multiple agile teams to provide quality solutions.
The brief for our project was for it to be centered on a user or a problem. Individually, we took some time to think about problems we have faced and explored app ideas on a Miro board. We came to a unanimous decision on our problem statement. For many of us, our fondest memories are being surrounded by family and home-cooked meals, traditional family recipes which are passed down through generations. Our problem statement tackles two issues. Firstly, recipes jotted down on a slip of paper or in a cookbook, filled with tons of sticky notes, are loose leaf papers which are easily lost and disorganized. Secondly, some family recipes are yet to be recorded. Including photos to accompany each step of the method, it can be a cumbersome process when recording and cooking a recipe. It's not easy to correspond photos saved on your device with a written recipe. The problem statement resonated with us all. As a diverse team, we could all relate to the wanting to learn and preserve recipes from our respective cultures. We started with Disney ideation to explore ways in which we could tackle the problem and refine ideas. To further understand the problem and identify a solution, we carried out some market research. We spoke to family and friends, and we also reached out to the wider School of Code community along with our social networks. We sent out a survey which received nearly 70 responses. This helped us to understand the features and functionality most important to our users. Finally, we researched existing solutions for current recipe organisation apps. This helped us to identify what was required as part of our MVP. Using the data, we began thinking about Food Story users and our target audience.
We learned the key functionality our app required was to enable a good search function so a user can always find what they're looking for. A common theme from users was the ability to add photos of the finished recipe or through the method stages. And finally, a place users can add their own notes to the app. User stories were also important as part of our research. Our app can cater to a diverse target audience, so the user personas helped us focus on who our user would be and their wants and needs. Our target audience are family-oriented, busy working professionals living away from family. The user interface has to be easy to navigate, use, and accessible for users. The user stories helped us to identify what functionality is important to them.
I'll now take you through a demo of our Food Story app hosted on Netifly. When you navigate to our app on a laptop or desktop, you are greeted on the welcome page with a short video of a family enjoying a meal together, along with our name, Food Story. The login button prompts the user to log in. We chose Auth0 to handle user authentication. This allows the user to choose between using a username and password or to use their existing Google account details to log in. When a login method is chosen, the user can continue using our app. Once logged in, a user is directed to the home page, where they are greeted by all of the recipes that are currently saved in the application. In the center of the home page, we have a clear search bar where a user can input an ingredient, title, or tag, which will return the user a series of recipes which include their search term. A user could also click on a meal type button, which also shows the recipes for that meal type category. When a user clicks on the Show Recipe button, they are directed to another page which shows the recipe information as input by the user. This includes an image, tags, ingredients, and the method alongside the story behind the recipe. If a user wishes to make amendments to their recipe, they can simply press the Edit button. Where they are redirected to an Edit Recipe page, which is pre-populated with the existing recipe data. Here, any changes can be made to the recipe and saved, following which the user is redirected to the home page. Also, from this recipe page, a user can delete a recipe. The user is notified that once this action is taken, it cannot be undone. Finally, on a navigation bar, the Add Recipe takes you to a form where you can create the recipe. Here we also have the option to add a photo of the recipe. If a user tries to save a recipe without a title, story, or meal type, they are prompted to complete the recipe form. If a user has input all the items mentioned previously, they are then notified that the recipe is being saved. Once saved, a user is redirected to the home page. Finally, the Our Story page provides a summary of how Food Story came to be, a way to preserve the recipes that underpin our respective cultures. I'll now pass you to Rosanna, who will explain our MVP and wireframe design.
We brought our idea to life by ideating the low fidelity design using Excalibur, and when it came to high fidelity, we opted for Figma. We used Figma to design our front-end MVP and iterated on these designs. As you may have noticed, the final app does differ from the high-fidelity design we envisioned, and that is because, informed by user feedback, we felt Food Story too closely resembled the branding of a well-known supermarket chain. So to differentiate, we opted for an alternative colour in our palette.
We followed agile methodologies from the start, first gathering our requirements so we could create our plan. Then we decided on a design before starting our development. We used Jira Confluence tool to store our project documentation in one place for easy reference. We followed the agile development process of granularizing our user stories, features, and epics into our backlog. We ensured our user stories were small enough for one complete iteration. By splitting user stories into smaller user stories, it helped with understanding the problem and also helped to estimate how long it would take to implement. When splitting the user stories, we did so vertically rather than horizontally. We mapped the slices out on Miro, firstly, before moving them into Jira. Jira provided us with the tools to break down the complexity of the problem into epics and issues. This allowed us to set milestones to achieve our MVP and keep track of them using the roadmap and Kanban. We also utilised flexible pair programming to rotate pairs over the 4 weeks so that we could help reflect our thoughts on how to solve problems with our partners. This improved morale and collective code ownership, also provided opportunities of mentoring. As a communication is essential to work effectively as a team, We had daily stand-ups with three cornerstone questions. What did you do yesterday? What will you do today? And what blockers stood in your way? After our stand-up, one member of the team would go down to the stand-up of stand-ups to discuss what we planned and any blockers we may have. We could then seek support if we needed or offer support to others. For our daily end-of-day retros, we used 4L's retrospective technique of liked, learned, lacked, and longed for, which provided opportunities to support team members who may have had a bad day, or also share learnings about something that was good.
Talking about the tech stack of our application, we used a wide variety of tools and technologies. Our project is a punch-stack application that uses PostgreSQL as a database, Express as an application framework, React as a user interface framework, and runs on Node. On the front end, we use Next.js, Chakra and NextUI libraries, and NextAuth for authentication. We used Next.js over the Create React app framework because it provided image optimization for a recipe page. Our team found file system routing easier to implement. For authorization, we implemented NextAuth SDK and integrated Auth0 with it. And we protected all the app's pages via token authentication. We used Cloudinary for image storage and storing the image URL returned by Cloudinary to our database. Our backend is based on Express framework that runs on Node.js. We have used REST APIs to instruct our DB what thread operations need to get done. For our database layer, we compared and tested DynamoDB, MongoDB Atlas, and Heroku PostgreSQL. Our team settled on PostgreSDB hosted on Heroku as it makes querying simpler, and we were all familiar with it. At various points during the week, we decided to split into 2 to 3 teams and work on the different parts of our app. To avoid conflicts and to ensure that we were not adding new features directly to our main branch, we used the dev branch setup weekly. We branched off the dev and appropriately named them to the feature and/or author. Having semantic commits made reviewing and merging branches easy to understand. We always did the merge as a group of 6 after a quick code review. We deployed our app in Netlify to the very beginning of the project so as to implement CI/CD, continuous implementation and deployment. In this way, we made sure that the deployed version is still functional.
In this project, we have used Cypress because it's a very powerful tool that makes it easy to set up, write, run, and also debug tests. And for the backend, we used Supertest. We were able to test both the HTTP status and the body. One of our biggest learning is the importance of test-driven development. In future, we'll opt for TDD so as to detect issues at the early stages of design and development.
We liked the approach and functionality of Next.js. It was a big learning curve for us. We know that we have not used it to its full potential. Customization have been challenging with Next.js as syntax differs from the usual React way, such as there is a limitation of dealing with roots and images in Next. Most of the available docs are compatible with React but not with Next.js, so we had to mostly find a workaround to deal with UI libraries or Cloudinary for instance. As we use Next.js, which we all were not very familiar with, it was definitely a learning curve for us. But we want to acknowledge our mentors, our coaches, and fellow bootcampers and the School of Code community for helping us out whenever we faced a blocker, and they were always there to help us and overcome the challenges.
Going forward, we would like to implement some stretch goals. In our front end, users will be able to see the personalized dashboard of the recipes, including nutritional information and calories. That's if the user has opted to view them. Also, users should be able to share their recipes with other users of the app. Furthermore, we would like to add a function that can generate a shopping list from a user's weekly food menu.
Thank you for taking your time to watch this presentation. If you have any questions, please feel free to contact the members below. Bye.